So on this problem, so now that we know how everything is lined up, right? So everything's related to the number of threes. So I'll call this one X. And since the 2-point shots are 4 more than threes, this is X plus 4. And the number of free throws is the sum of 2s and 3s. So this is X plus 4. Because that's the number of threes and that's the number of 2s. So now I know that all of these together make 26 points, right? So each of these bottom ones are worth 3 points. So each of these x's on the bottom are going to be multiplied by 3 because they each get 3 points. The one in the middle are each worth 2. So there's 2 times x plus 4 of those. And the ones on the top are each worth 1. So it's just, I could put a 1 outside of it, but it's just x plus 4. And that makes the total number of points. So the x's are the number of shots that were made, and then you have to put the points with it. So now we have 3x plus 2x plus 8. And I'm just going to simplify this. 1x and 1x makes 2x plus 4 equals 26. So now 3x, 2x, and 2x, that makes 7x. 5 and 7. So those are done. 8 plus 4 makes 12 equals 26. So now I can minus the 12. So 7x equals 14. Divide it by 7 and x equals 2. So now I can go back through and I can put everything where it belongs. So the number of threes, he made 2 threes. 2 plus 4, so we made 6 twos. And then 2 plus 2 is 4, plus 4 more makes 8. And you should be able to check your work and make sure it's right. 2 times 3 makes 6 points. 6 times 2 makes 12, plus 8 ones. That makes 26 points. So that worked out right. So 2 threes, 6 twos, 8 foul shots. So on this one, we're going to have to set up 3 equations again. So the first equation is that A plus B plus C, they cut, so all of these are in 7,200 feet. So all of these rates they cut 7,200 feet. So that makes it easier because we can just say A plus B plus C equals the time, not the number of feet. Because all of these are 7,200. So it takes the A plus B plus C 6 hours. Takes A plus B 9.6 hours. And it takes B plus C 9 hours to cut. So they're all cutting equal amounts of wood. So like I said, that makes this problem a lot easier. If they would have cut different amounts of wood, then that would have really changed things up. So I can set it up like this. Now I'm just going to use elimination. What variable do you want to get rid of? A, B, or C? You make me choose. Okay, we'll get rid of C. I'll multiply this bottom one by negative. And I'll add it to the top. So I'm combining the top and the bottom one. So that's going to be A. Both B and C go away, right? That's no bueno. A plus B plus C equals 6, but then if I combine the bottom with it by multiplying by negative, I get A equals negative 3 hours. That can't be right. So instead of putting time on here, since that didn't work, let's try putting a rate. That's the problem asked for that. So A plus B plus C, let's put, that's 7,200 linear board feet in 6 hours. A plus B is 7,200 feet in 9.6 hours, and B plus C is 7,200 feet in 9 hours. So now we've got to calculate what the 7,200 over 6 is. So 72 divided by 6 is 12, right? So that's just going to be 120. I don't know what 7,200 divided by 9.6 is. What is it? That's got to be 1,200. Okay. And 7,200 divided by 9. So now let's do the same thing. Multiply the bottom one all by negative. I don't think you can see that in it. Purple. Blue's not a lot better. So now if I combine that with the top, so I'll have A plus B plus C equals 1,200. And then combine that with the negative of the bottom one. We get that A equals 400 linear feet per hour. And now I know I can look at the middle one, and I know A plus B equals 750 linear feet per hour. And since A is 400, I know that B has to be 350. And now I can look at the bottom or the top. It should work the same. I know what B is. So B plus C has to make 800. So C has to be 450 feet per linear feet per hour. And if I check it up on top, it should work. So 400, 350, 450 better make 1,200. So that makes 8, 4, so that checks out. So anyways, after I made this mistake, that was better. Worked out. So on 52, you're supposed to come up with the equation of a parabola, given that it goes through these 3 points. So these 3 points, on each of them, it's an ordered pair of x, y. So you're going to come up with 3 equations using these 3 points. Then you have 3 equations and 3 unknowns. So the unknowns are going to be a, b, and c. So you know the x and y, you just don't know what a, b, and c are. So we plug this in, so on the first one we're going to have negative 4 equals a times 0 squared plus b times 0 plus c. So that's plugging in x is 0 for all of the a's and putting y in for the y. So now in the next one I do the same thing. This y is negative 6, a, the x is 2, so 2 squared plus b times 2 plus c. And then on the last one, the y is negative 31, a, negative 3 squared plus b times negative 3 plus c. So now we have 3 equations with 3 unknowns. We've got to simplify each of these so that it's not a number squared, so we just have a number times a. So on the first one, it works out pretty nice because 0 times anything is going to be 0. So on the first one, we get that c equals negative 4. So that makes it nice because we now have c, and I can replace that in these other 2 equations. So in the middle equation, 2 squared is 4. So I have negative 6 equals 4a, b times 2 is 2b, and c is negative 4. On the bottom equation, we have negative 31, negative 3 squared, so negative times negative is a positive, so that's 9a, negative 3 times b, so negative 3b, and c again is negative 4. So now I'm just going to move that negative 4 to the other side on both equations. So on that top one, I add the 4 to the left, so I get negative 2 equals 4a plus 2b. On the bottom one, I add the 4 over. Whoops. So negative 31 plus 4 is negative 27 equals 9a minus 3b. So now I have two equations to work with. I have negative 2 equals 4a plus 2b, not b, 2b. And I have negative 27 equals 9a minus 3b. So now we want to use elimination and get rid of a or b. I'm going to use b just because 2 and 3 will go into 6 versus 4 and 9 go into 36. So this is a smaller number to work with. So I'm going to multiply this one by 3 and this one by 2. So I get, just going to move it over. Maybe not. So I get negative 6 equals 12a plus 6b. And down below, negative 27 times 2 is a negative 54 equals 9a minus 6b. Thank you. That was not going to work out nice. So 18a, so negative 60 equals 30a divided by 30. We get that a equals negative 2. And so now I can plug that into the purple one or the red one, either one. So I'm going to plug it into the purple one. So I have negative 2 equals 4 times negative 2, which makes negative 8, plus 2b. Add 8 to that. So 6 equals 2b, divide it by 2, and b equals 3. So my final answer is now the equation. So y equals negative 2x squared plus 3x minus 4. So that's the equation of the quadratic that goes through those three different points. So on these problems, these ones are rough because you can't use elimination because that's x squared and y squared, and you don't want to multiply this by x to make it x squared because you're not going to eliminate x's. If I multiplied it by x squared, I'd get this. And so then when I combine them, yeah, the x squared would go away, but I'd still have x's in my equation. So you can't use elimination on this yet. Well, on this kind of problem. So what we have to do is use substitution. So I'm going to solve for x or y. It doesn't matter which one. So if I solve for y, I'm going to minus the x over. So I get y equals 1 minus x. So now that I know what that is, I can take what this y value equals and plug that in for this y right here. And the reason this is a lot harder is because you still have to square this 1 minus x. Because we've just replaced the y, but the squared is still there. So the 1 minus x quantity squared means I have to take this out and write 2 parentheses and do the distributing. So 1 times 1 is 1, 1 times negative x is negative x, negative x times 1 is negative x, and negative x times negative x is positive x squared. The x squared that was in front is still there, so that's what we have now, so we can combine like terms. So 1x squared plus 1x squared makes 2x squared. Negative x and negative x makes negative 2x. And I want this to equal 0, so I'm going to minus the 25 over as well. So negative 25 and positive 1 make negative 24. Now to make the problem more simple, I see that all of these are divisible by 2. So since they're all divisible by 2, you can divide everything by 2. Because then we don't have to deal with as big of a number. So we have x squared minus x minus 12 equals 0. So now I have x squared minus x minus 12 equals 0. So I'm going to try to factor that. Multiplies by x squared is x and x. Multiplies by negative 12 and adds to be negative 1. That's going to be negative 4 and positive 3. So now that I've got it factored to here, I get x minus 4 equals 0. Put each factor equal to 0. And then we can solve. So we get x equals 4, x equals negative 3. So on these, there's going to be the same amount of answers as there are powers. So x squared has a power of 2, so there's going to be 2 x's. Unless they don't ever meet, and then you won't have any answers. So it'll be undefined. It'll be an I, and then you'll know they don't meet. So now to figure out the y values, I plug in these x values one at a time. So y equals 1 minus 4. So 1 minus 4 is negative 3. So when x is 4, y equals negative 3. So now I plug in the other x value. I have 1 minus a minus 3. So minus a minus turns into a plus. So when x equals negative 3, y equals positive 4. If you were to visually graph this to make sense of what's happened, what's x squared plus y squared equal 25, the equation of? If they're both squared, it is a circle, right? So really what you have is you have a circle of some shape. It's supposed to be a circle. And you have the equation of a line, y equals 1. If I wrote it this way, y equals negative x plus 1. So down 1, over 1, down 1, over 1. So really what you have is you have the equation of this line and this circle. And this point right here where they meet, this is when x equals negative 3 and y equals 4. And this point where they meet is x equals 4, y equals negative 3. So that's really what you're looking at, is where do these two equations, where do the lines intersect on those? And so if you want to check your work using Desmos, you could, because you could see where they end up crossing. You could type them both into your Desmos equation and see what happens. I had somebody do it a few years ago. They just used Desmos completely, and then on their homework, and then when they got to the test, they're like, "Can we use Desmos?" And I'm like, "No, you have to know how to work them out." And they're like, "Oh, but I don't know how. I just use Desmos." I'm like, "That's your fault." So anyways, make sure you know how to work them out. So on this one, see how it has x squareds and xy's and xy's, like they're the same term, like the same creatures. If they're like that, we can use elimination. And so I'm going to get rid of the xy's. I'm going to multiply this top one all by 3. So that makes it 3x squared minus 3xy equals 60. 3. The bottom one is 2x squared negative plus 3xy equals negative 44. So now when I combine those, a great thing happens, and these go away. So then you just have 3x squared minus 2x squared, which just makes x squared. And 60 minus 44 is 16. So now all you have to do is take the square root of both sides, and you get that x equals, and remember when you take the square root, it gives you two answers. X equals plus or minus 4, so x equals 4 and x equals negative 4. So now that I know what x is, to figure out what y is, we plug it back into either one of these two equations. I'm going to use the one that has smaller coefficients, so I'm going to use the x squared minus xy equals 20. So I have 4 squared minus 4 times y equals 20, and over here I have negative 4 squared minus negative 4 times y equals 20. So I use the same equation both times. Um, that's better with the parenthesis there. So now I just pick to solve one of them. So 4 squared is 16. So I'm going to minus 16 from each side. So I have negative 4y equals 4. Divide it by negative 4, and y equals negative 1. So when x equals 4, y equals negative 1. And you could put that as an ordered pair. On all of these, you could put an ordered pair. So now I need to do it for when x equals negative 4. So negative 4 squared is 16. A negative and negative makes that a plus. 4y equals 20. So now I minus the 16 minus the 16. 4y equals 4. Divide it by 4, and y equals 1. So when x equals negative 4, y equals a positive 1. So that's how you can do that section that says use elimination. If they're the same kind of a creature, you can multiply them by what you need to get the coefficients the same and add them, then they'll disappear.